Hi everyone, welcome to my channel Pure Biology, and today I come with another video that is related to topic LOTKA VOLTERRA model. And already I have explained this model, and you can check out this explanation in my channel, which has already uploaded. And here I will try to explain the different topics, or different not topics, different cases related to this model, where the species 1 and the species 2 both are involved, and what is the effect of this species 1 and species 2 carrying capacity of their, how they affect with each other. So we will learn here. Okay, so here the first case, generally four different ways or four different cases are seen related to this zero isocline, not inclines. This is the isocline, I think. Isocline, yes. Zero isoclines. So what is zero isoclines? I have already explained. So these terms and other also terms, that is carrying capacity alpha 1 2 alpha 2 1, these are all stated here but not explained here. So before going to this topic, you have to understand what is the carrying capacity and what is this alpha 1 2. That means this model first you have to learn. Okay, then you can see this video where I here that try to explain about the different cases that related to this model. So here the two species 1 and 2. In the first case, where the two isoclines, one isocline for species 1 and another isocline for species 2, not cross to each other. Okay, they remain parallel like that. Okay, they remain parallel, and here the isocline of species 1, it is remained above and to the right of the isocline for species 2. That means here the isocline for the species 1 that remain above. Okay, and just in the right side. Above of what? Above of the species 2 isocline. Clear? And here the actual thing happening, that K1, it is the carrying capacity for species 1, and K2, this is the carrying capacity for the species 2. Here the K1 by alpha 1 for species 1 and 2 for alpha species 2 for species 2. Okay. So what is this? You just check out that one video. Okay. So this is the alpha 1 2, not 12. 1 for species 1, 2 for species 2. K1 by alpha 1 2 greater than the K2 carrying capacity of species 2. So if you rearrange this one, then you can see that K1 carrying capacity is greater than the K2 alpha 1 2. Just cross multiplied with this K1 alpha 1 and 2 with the K2. And here another thing is that K1 greater than K2 by alpha 2 1, 2 for species 2 and 1 for species 1. If this thing is happening, that K1 greater than K2 by alpha 2 1, so in that situation, if rearrange you this one, then you will get K1 alpha 2 1 greater than K2. So either you can get this one or you can get this one. But in the both cases, which species is strong? The species 1 is strong. Okay? Because K1 is greater than, in the both cases, than the K2. So here the species 1 is the strong interspecific competitor than the species 2. So what is the outcome? The species 1 goes to carrying capacity K1 and species 2 is competitively excluded. Clear? So whose carrying capacity goes on? the species 1's carrying capacity that goes on, but the species 2's carrying capacity that be excluded. Okay, so here this is the graph, and you can see the species 1 is the isocline of the species 1, that is above. So here the existence of this species 1's carrying capacity is remain, but species 2's carrying capacity excluded. Okay, lower than this. In the second case, there also the two isoclines are not crossed, but here the species 2's isoclines that remain above the species 1's isocline. Okay, sorry. Okay, so here same thing happened, but the K2 in the both cases greater than the K1. The carrying capacity of the species 2 is greater than the carrying capacity of the species 1. So here the outcome is that species 2 goes to carrying capacity K2, but K1, that is for the species 1, that excluded. Okay, species 1 carrying capacity excluded, only remain here the species 2's carrying capacity. And obviously here the stronger species is the species 2. These are the interspecific strong competitor. Okay, these are the two types where the two isoclines are not intersected. But third one, here the intersection is seen. Okay, and here the intersection is seen that the both isocline cross with each other, and both species carrying capacities are lower than the one thing is that the both the isoclines cross one another, but the carrying capacity are lower than the others. One's carrying capacity is lower than the, not like that. One second. Okay, just I have forgotten to write this equilibrium point. Okay, so what is happening here? Here the case that is the stable coexistence. Stable coexistence means here the both the species they are stable, not in the greater than the others. Okay, they are both stable. In both cases, the carrying capacities for the both species, the carrying capacities are lower than the others, divided by the competition coefficient. This is the competition coefficient. Okay, that means here the situation is that this division or this thing, that means where the carrying capacity of 1 divided by the competition coefficient, this will be always greater than the carrying capacity. Clear? So in same case, same thing is here, that one carrying capacity that is divided by the competition coefficient, this will be greater than the carrying capacity of the other. Okay. So here if you rearrange this, then in the first case the K1 is greater than, and the second case the K2 is greater than. That's why here the two lines you can see both intersect at a point, and this point is known as the equilibrium point. Okay, and the two species, both species, they they remain unstable, or they the competition of their that is always be stable in that point. Okay, so this is the outcome, and both the species have the less competitive effect on each other, as these two species stable at a point. This is called the equilibrium point. That's why they both have the less impact with other or on other. That means one has the less impact on the other. Suppose you can see that species 1 has the less impact on the species 2. Same way, species 2 has the less effect or less impact on the species 1. Okay, that means both the species have the less competitive effect on each other. Clear? So this is the stable, and the last one this is the unstable, and I will explain after rubbing this one, okay, or cleaning this one. Okay, this is the unstable coexistence. What is this unstable coexistence? Here, the thing is that the two isoclines, that is the isoclines of the species 2 that cross the, sorry, not species 2, both the species. Isoclines of the both species cross one another. And here, the carrying capacities always higher than the competition coefficient. Simple is that carrying capacity is higher than the competition coefficient. Okay. So, in case of species 2, K2 greater than K1 by alpha 1 and 2, this is the coefficient, or K1 greater than K2 alpha 2 1. So, if we rearrange this, then K2 alpha 1 2, just cross multiplication is done here. K2 alpha 1 2 greater than K1, or K1 alpha 2 1 greater than K2. Okay. So, this unstable, in this unstable coexistence, there a point you will get. This point is called the unstable equilibrium point. Okay. Where the two isoclines cross each other, so intersect each other. This point is called the unstable equilibrium. And in that case, individuals of both species have a greater competitive effect on the individuals of other species. That means both have greater impact on each other. And outcome is that unstable coexistence is seen between the species 1 and species 2. So, competition is very high, and if species 1 and species 2 both are competitively active here in this unstable equilibrium point. Clear? So, these are the 4 cases related to this model, and how this affect the species 1 or 2, or affect the same species 1 and 2. Maybe they remain in equilibrium situation, but that means the stable situation or unstable situation. So, these are the 4 different ways. One is the stable, another is the unstable, and another 2 types where the 2 isoclines they run parallelly. But here also in the 2 that run parallelly, here also sometimes species 1 has an impact on the species 2, or sometimes species 2 has an impact on the species 1. So these are the 4 cases I have explained here. So you just check out the first, the model, LOTKA VOLTERRA model, and after this you can see this. Otherwise you cannot understand what is these cases related to the model. Okay. So continue with my channel. I will explain another topic in my next video. So please continue with my channel. Thank you.